Hi, our capstone project is contactless DC battery charging in underwater environment, sponsored by General Dynamics Electric Boat. The technical directors overviewing this project are Michael and Robert. The team consists of 3 electrical engineers.
Hi, I'm Caitlin.
Hi, I'm Tim.
And I'm Arthur. And we are Team Contactless DC Battery Charging. So just a little bit about General Dynamics Electric Boat. They commissioned the first U.S. Navy submarine. They are the prime contractors for the Virginia-class submarine program. And right now, they're developing the Ohio replacement third-generation ballistic missile submarine.
So our project motivation is mainly focused on how the next generation systems will be different from what is in use now. The AUVs will be more reliable in how they charge because they won't need to physically be in contact with the subs, which will increase platform flexibility and support a range of voltages in seawater conditions. So first, we needed to find and assess our technology options. The 5 technologies we found were EM induction, electric field coupling, RF reception, magnetic resonance, and resonant wireless power transfer.
The anticipated best outcomes for this project is to develop a contactless DC charging concept model for use in an ocean environment and to develop a prototype to support a proof of concept demonstration.
To summarize our team's key technical accomplishments towards achieving this ABO, we started with background research on 3-phase AC power and AUVs. Next, we identified technologies of interest that we could use to develop the wireless power transfer system.
We then created our Pew matrix down selection. This was the tool we used to compare all of our technologies of interest and ultimately decide on which one we would end up using for our prototype. This leads me to our next accomplishment, which was our ANSYS Maxwell simulations. ANSYS is an FEA tool that simulates how certain technologies would work in a specific environment. More details about simulations will be mentioned later on in this presentation. This project could have a huge impact for this company by first helping guide development and concept of operations. It could increase platform flexibility, enable new missions to take place, and make AUV deployment more reliable. This is our system block diagram. It is an overview of our wireless power transfer system. Next, I will be talking about my technical contributions. So my first technical contribution was to look for technologies of interest. One technology I researched was microwave wireless power transfer. Microwave wireless power transfer with a frequency range of 300 MHz to 300 GHz enables power transfer from up to a few meters. The microwave wireless power transfer system consists of an energy radiating antenna and a secondary antenna, which converts the microwave power into DC power. However, our research unfortunately determines that this technology isn't compatible with the underwater environment. My next contribution was to research the application of shielding coils. I learned that a system with shielding coils performs better because its maximum efficiency is higher compared to a system without shielding. Some future contributions I plan to make mainly involve finding hardware that we will need so we can start putting our prototype together. I will be focusing on the shielding, creating the environmental conditions for testing, and researching how we will be accessing the potting and molding compound PR1547, which is needed to shield the electrical components from the elements. And now I'll pass it on to Tim.
The technology of interest that I focused on this semester was resonant inductive coupling. Resonant inductive coupling transfers power through the near-field magnetic coupling of coils. This technology's utilization of resonant coils enables it to have a more efficient power transfer over a larger separation distance when compared to EM induction. I also worked on several ANSYS Maxwell simulations of different technologies. One of these simulations of EM induction is shown to the right. This shows the B field density between two coils, the primary and secondary, in EM induction. Some future contributions I plan to make focus on requiring hardware and fabricating the prototype. Specifically, I'll be working on designing and creating the secondary coil, as well as the rectifier circuit, which will be responsible for changing the AC power to DC power in our wireless power transfer circuit. I will also be continuing ANSYS simulations on various coil designs. Now I'll pass it off to Arthur to talk about his technical contributions.
For my technical contributions this semester, I also focused on researching technology of interest, specifically EM induction, which is running a current through a coil that produces a short-range magnetic field that will run an electric current through a different coil within the field. This power transfer works well only in a very short range of distance. This is why we have chosen resonant inductive coupling as the technology we will be using in our prototype. I also worked on ANSYS Maxwell simulation, some of my work shown in the pictures below. For my future contributions, I will be designing the primary coil and working with AC three-phase power to power our system. And I also will be working on ANSYS simulations once again for our prototype design.
Some of the future technical accomplishments our team would like to achieve include procuring the required hardware for our prototype, fabricating our prototype, the laboratory testing of the electrical components that make up our prototype, as well as the prototype itself. The laboratory test results will include additional engineering analysis as well as documentation. Finally, we would like to be able to demonstrate our concept hardware. Our confidence level for achieving this ABO is a 7.5 out of 10 based on our team's overall progress and ability to overcome the issues we've run into so far. Some risks we've identified while working on this project include being unable to access three-phase power on campus, not being able to access SolidWorks and other technology on our personal devices, COVID-19 exposure, being unable to find a technology of interest which meets all the specifications required for this project, and difficulty with the finite element analysis tools.
We would like to thank our technical directors, Mike and Rob, for giving us their time and guidance. Also, Professor Dr. Sunik for putting together this capstone project with passion and urgency. And last, we would like to thank Mike, Jack, and Brendan for assisting with the capstone program and helping with our project and risk management setup.